Now let me put, this is for n is equal to 0, now let me put n is equal to 1. Y of 1 is equal to x of minus 1, which is again 0, because this is my index minus 1, this is my index minus 2. Then I say n is equal to 2, y of 2 is equal to x of 0, and I know x of 0 is 2. Then I say n is equal to 3, y of 3 is x of 1, which is 1. Then I say n is equal to 4, and I know onward, because x of 2 is 0, onward it is 0. So it is, my new signal is 2 at index 2 and 1 at index 3. So if I, let me just take another red color maybe. So if I plot this, okay, at 2 it is 2, at 3 it is 1, and it is 0. So this is my x of n minus 2. So that's why I said whenever you want to resolve this, just take this and put it equal to 0. You will know where your 0 has moved. Okay, just take your 0, then move it to that location. So if you put this is equal to 0, it will tell your 0 is moved to 2. If it is minus n, if I ask you to do this, x of, if I ask you to do this, x of minus n plus 100. This is the effect of delay. That something which you acquire at 0 time, now you are playing it back at time 2. Okay, this is the delay. क्योंकि time axis चल रहा है, जब इसको आप convert करेंगे, this will be your 0 second. Okay, so आपने उसे you captured it, you delayed for 2 samples, whatever the sampling rate is. Okay, let me not do this at this point. But so even if I ask you x of n minus 1000, you can simply just take this, and you don't have to do all of this for 1000 samples. You just take it and plot it again at 1000. You say it is 2 and it is 1. 1000 and 1001. And here this example shows a sine of omega n minus 10. And very interestingly, in MATLAB I have to add n plus 10 in order to get this. Okay? So you need to figure out why. But in MATLAB you cannot do this, n minus 10. This is what is happening mathematically. But in programming you need to do something else to get to this thing. This is the part which I'll just conclude my lecture with. I think I can turn this off and do it here, and then maybe. Okay. This is the most interesting part of this lecture. You say delta of n is this. Okay. And if I ask you what is delta of n minus 1, so it is just move to 1. Okay. If I ask you what is delta of n minus n plus 1, it's something which is moved to minus 1. Okay. What if I ask you what is 3 delta of n? It's just you are multiplying delta of n by 3, so it is 3 and something which is 0. Okay. And I ask you what is 2 delta of n minus 1. That is, you have an impulse amplitude 2 and at location 1. Okay. Then I ask you, okay, I have this signal which is at -1, 0. These are the indices, -1, 0, 1, and 2. So amplitude is 1, here amplitude is 2, here amplitude is 1, here amplitude is -1, this is n, this is x of n. And I which is at -1, 0, these are the indices, -1, 0, 1, and 2. So amplitude is 1, here amplitude is 2, here amplitude is 1, here amplitude is -1, this is n, this is x of n. And I ask इस तरह से ऐड होगी. But you can very conveniently again write 1, 2 delta of n plus 1 delta of n minus 1 and then minus 1 delta of n minus 2. Let me just what's it doing? Okay. So another thing, if you remember, I told you like you can also write this as x minus 1. I told you that you can represent the signal, you can say the value of the signal x of n at -1. This is the amplitude, which says is 1 dot delta of n plus 1. Okay? And these are the type of things we'll keep seeing in this course, so just make yourself convenient and comfortable with these type of symbols. And then you say 2 is in fact x of 0 delta of n. And 1 is in fact x of 1 delta of n minus 1, and then plus x of 2 is in fact, so whatever sign is here, you have minus of it as the index of that signal. Okay. So you have here 0 minus 0 is same, minus 1 here you get 1, minus 2 here you get 2. Okay. So it means that I can represent any signal, so it can go on both direction like this. Okay. If it is in negative direction, you keep just writing it like this. If it is at positive direction, you keep writing it like this. And then I can just, in closed form, I can write it like this. X of n, my signal, can be written as k goes from minus infinity to positive infinity, x of k delta n minus k. ये चल रही होगी. If you want, you can take that CD and copy it. And जो एक और CD मैंने कहा था, it's about 400 megabytes, so it's really not possible for us to make copies, so many copies of that CD. So maybe we can make 2-3 copies, and then either you can do it yourself and tell us, we'll go to the market and just get it copied for everybody. See, the CD which I was talking to you about.